Hi everyone, and welcome back to Having Fun Repairs. I've got this Crate amp back up on my desk, the G80XL. I actually had pre-recorded some things that I lost on my hard drive, but luckily I hadn't done any physical work to the board yet. Haven't dismantled it yet. I just spent some more time with the service literature I found. That was about it. So I kind of want to go over some additional things that I've uncovered. Okay, the first thing I noticed on the diagram was that our low, medium, and high potentiometers on the original diagram that I downloaded, bottom right hand will show you. It's for even though the title of it was GX80, GX212, the actual schematic says GX120, GX212. Again, the amplifier itself is a G80XL. But anyways, I'll scroll back up. So there's already a disparity there. So I may or may not mention this. This might not be a one-for-one, and it definitely turned out to be the case. So if I'm looking at channel B here, and I look at my high, low, and mid potentiometers, high is 10K, low is 10K, and mid is 500 ohms. However, on the actual G80, the potentiometers are not that. Okay, if I can get this to focus somewhat. This one right here should be my low. You see that number there is 50. Yeah, you got some numbers in a dash, but right after that dash you have 53. So what that stands for is 50 with 3 additional zeros. That's a 50,000 ohm pot. For my mid right here, you have 202. So 2 0, 2 more zeros. That's a 2,000 ohm pot. And then for the high, you have another, let's see if I can get this focused, another 53 or 50,000 ohm pot. Okay, so found this diagram, GX80. Again, my amp is a G80XL, not GX80. Here goes the old diagram that we were looking at. And as I showed you, the high, low, and mid are not what we physically have on our circuit board, but they are on this amp here. You see for the high a 50K, lows of 50K, and the mid-range is a 2K potentiometer. That's good. Now what this diagram is missing is it's missing channel A. This is only channel B. So I think I can use this. I think it would be a one-for-one. We also have some test measurement values over there. But like I said, this one right here has channel A, excluding channel B. Now, because this is basically a audio crossover type circuitry, you kind of tune your pots with the use of resistors, inductors, and capacitors. Now your capacitors essentially are going to block low frequency, only pass high frequency. Inductors would be the polar opposite. Somebody will need to fact check that on the old Google, but at least off the top of my head, I believe those two components work. Now if you look for these 10K pots, 10, 10, and 500, the capacitance value is going to be different. We've got 0015 microfarad, 2.2 microfarad, and then a 1 microfarad here. Then over on this side we have a 0.001 microfarad, 0.22 picofarad, I think, another 0.22 pico, and another 0.22 pico. I believe those will be pico, and I think that also matches up with what we have on the board as well. Now, some audio files you can put down in the comments below for me, but I'm fairly positive if I wanted to change how my guitar amp sounds, and then I could change the tone with my tone controls by eliminating all these components here, and then I would have to include all of these components right here prior to this amplifier. Which also brings me to the amplifier itself, and I'll show you this here in a second. Let me bring up my internet browser, make it bigger. So what is on the board is RC4558 Ps. And then here goes the pinout for them, 1 being closest to the dot. So you have, let's see, out 1, inverted in 1, non-inverted in 1, negative VCC, second non-inverted in, second inverted in, 2 out, that's going to be your audios, out 1, out 2, and then your positive VCC rail. But over on the diagram it showed TL072s, and here goes the TL72. Comes in quite a few different 8-pin form factors, D, DDF, JG, PPS, 8-pin SOIC, SOIC, whatever. I believe some of them are probably just surface mounted, some are through hole, etc. But anyways, it's the exact same pinout for this guy. And then when I decided to just look over and compare them, the data is primarily the same. They're both 3 megahertz, both have 3 megahertz bandwidth. 4558P actually states in the literature that the absolute max VDC in would be 18 volts DC, but the preferred range is 5 to 15 volts. I didn't see that 18 volts for the TL072, but it did give us either positive 5 to 15 volts DC on VCC plus, and then negative 5 to negative 15 volts DC on the VCC minus. And we'll check those two in a minute. I also looked these up online, and there seems to be the audiophile guys seem to argue over which one is better. There are actually there's other data in that data sheet that somebody else can digest. I'm not shifting through it all, but it seems to be that the most preferred replacement is the TL72. So I probably interesting to note there. So we've got a few more things that we need to check out on our circuit board. Oh, one last thing. Actually, spending time with this also taught me that I tested my audio incorrectly. I was trying to go off the potentiometers, where what I should have done is gone off of the output of one of our ICs. So we're going to do that as well and redo that math. So apologies for re-going over a couple things, but I'm pretty sure it's a lot of smarter people in the comments waiting to yell at me about that stuff. So I figured I'd just, go ahead and just do that portion over again. Now I do want to note that on this diagram that says GX80 and has the same audio pots, trimmer pots. Under condition 1, channel B, you have test points. Now, I'm not going to set so many things per this instruction, but if you look at it, it says volume, high, mid, and low at 10, bright off with load input signal 82 millivolts peak to peak. Now, I'm checking my volume high, mid, and low, so I'm not sticking it at 10, but I am putting my input signal at 82 millivolts peak to peak. You can verify that right here, 82 millivolts peak to peak. Right now I currently have this set at a 1 kilohertz tone, but I'll change that here in a minute when we perform our tests. So first up, we're going to check our 80 hertz signal. What I'm doing right now is I'm just setting my level adjust for channel B at level control for primary amplitude, primary amplification. Now it's at mid right now. You can see that there's 552 millivolts on oscope. I'm putting it all the way counterclockwise, and I'm writing down. We basically have nothing, if anything at all. Yeah, nothing there. What did I say about? It's barely picking up. But we'll say 10 millivolts. That's 10 millivolts AC. But essentially nothing's there. Now I'm going to turn up the amplitude a little bit. There we go. Let me adjust my oscope. We're starting to get quite a bit of amplification. And it looks like we are maxing out at 3.48 volts. Okay. Now, if I was to mess with my low, mid, and high on the current OpAmp I'm testing, it makes no difference to this adjustment. I will mark that OpAmp with a silver marker. Actually, I'll mark it with a gold one so y'all know. Gold isn't necessarily showing up. Hopefully it will in a second. I'll show you in a second which one that one was. But anyways, I want to take this and set it at like 1 volt. I think that's a good voltage to set it at. Now, I have to go over to a different OpAmp. It comes time to making measured values of other things. Again, I'm going to turn this down real low, and we are getting at this OpAmp. Actually, what I did is I just turned my level adjust full clockwise going to the other OpAmp, so it's at full gain. I am on low, seeing about 64 millivolts AC. And as I start to increase my low, let's bump that down. I get all the way up to 5.92 volts. I'll just write down 5.92. I'll take the lower. 5.92 volts. Okay. Now let's change our frequency. Let's go to mid. Mid is tested at a 1 kHz signal. 1 kHz. Now I'm keeping my low at max. You can see when I turn it down, it affects that mid-range signal. So I'm going to keep it at max. Mid is fully counterclockwise. I'm seeing 760 millivolts. Now I want to go full clockwise. And I don't really get any amplification whatsoever on that 2K trimmer pot. So you can tell that that pot's pretty dirty. It's not until I get up to about 3/4 of a turn to full turn do you actually see any amplification. So one thing that this is going to tell me is more than likely this mid is an audio pot versus a linear pot, because a linear pot would do something like this, full up, full down. So let me make this bigger. The level adjust control is definitely a linear pot. You can see that it's going from small to big. But this but our actual tone controls, not so much. Yeah, it's full counterclockwise, turning it, rotating it right. And there's some points in there that are very iffy. I'm willing to believe that that guy needs to come on out. We'll check it with a multimeter once I have the entire board taken apart. But anyways, at max, I get 1.86 volts. Now I'm going to leave it at max. Man, if I turn my low up, it goes up even higher. Might have to test it that way as well. Let's see. Our high is 5 kHz. Mid, high, 5 kHz. Let me change that. So 5K. Right now I have both low and mid at max. High has not been adjusted. We're starting off with 2.2 volts AC. Now I'm going to turn up the high. Ooh, it's getting up there. We get all the way up to 17.12 volts. Now, for poops and giggles, I'm going to make sure that my level, low, mid, and high are all fully clockwise. My high values are not going to change, 2.2 to 17.4, but I'm going to redo my mid at 1 kHz. made at 1 kHz. The high value is now 6.3, and I'm going to go fully counterclockwise on the mid. .32 was fully clockwise. Let me make this bigger. Now I'll take that mid control fully counterclockwise, and still only a relatively small adjustment. 5.76. Okay, cool, whatever. Now let me take this down to 80 Hertz. So everything at max. 80 Hertz signal is now at 5.60. Now, first test was with everything at min and slowly incrementally going up. This test is with everything at max and then incrementally going down. So now let me turn this down and 1.42 volts. Okay. So I think it's worthy to state that the signal looked pretty clean at an input signal strength of 82 millivolts or whatever it was I set it to. But anyways, our low is saying 15 dB of boost. Or sorry, lead control 15 dB of boost. Now if I plug in my original lead values, we had 1.42 volts AC that went up to, oh sorry, the one's completely wrong. We had 10 millivolts AC, so 0.01, that went up to 3.48 volts. That's 50 dB of gain. Let's see, my low was 0.064 and it went up to 5.92. It's 39 dB of gain. My mid was 760 millivolts, 0.760, and it went up to 1.86 volts. That's 7 dB of gain. And then my high, and this was with level at max and keeping everything at minimum until I started going through stuff. My high starting value was 2.2 volts, and it went up to 17.12, which is 17 dB of gain. So that makes sense for the high at that max value. Now going back through, I've already punched it in, punched back in the mid. But when I leave everything at max, that mid was 5.76, adjusting to the low, and the max output was higher at 6.32. So yes, even less amplification. Now, oddly enough, if I put that input voltage down at the bottom of my low, which was 64 millivolts, and calculate, that's 19 dB of gain, and that's closer in line with what we have for our mid at 16 dB. So I'm wondering if I did the same thing for my low, everything at max, 5.6, I think it was, 0.6, oh, yeah, 5.6 volts. It's 18 dB of gain. And then high would still be 17. .28 dB of gain. That's still a lot of gain. But those are closer to the values, at least. 10, 16, 17. An incremental difference of 1 dB of gain between mid to high, and 6 dB of gain between low to mid. But anyways, kind of just messing around with the numbers to see what is actually a representation of these values over here without actually knowing the test procedures. So I'm going to say what the test procedure should be based upon the values I have is level adjust set to max. With everything counterclockwise, the lowest reading I got was 0.64. And then you would need to do that lowest reading for each frequency. So that 0.64 would only be for 80. I would need to punch in 1,000 and then 5,000 and measure it again for the lowest there. And that's all potentiometers at low minus level adjust. That would be at max. And then set all of them to max and then turn them counterclockwise to see how much gain or loss we have, or to see what the top most gain is that we have. And I think that's how you would do this measurement, because by these values, this is the closest I have for measuring these values. Now, one more thing I want to check while everything is still assembled. So, before I do that, just want to point out, I know it's going to be hard to see, there goes the gold one, there goes the silver one. So when I was measuring level adjust, just to see the amplification on it, it was on pin 1 of this one. And then when I was taking measurements to my tone controls, it was on pin 7 of this one right here. Okay, so 1, 2, 3, 4, 5, 6, 7 being at the top. Anyways, we need to check the inputs and outputs. Not sure if I did this in the past. It's been so long since I watched that part 1 video. But where can I put this? If I measure see, we're within range right now, but it's 5 to 15, but it's slowly creeping up. I've had this thing on for quite some time. 15. When it first turned on, it was closer to 16, 17 on some of these. Yeah, see, that one's close to 18. I wonder if this guy is starting to go out, the input voltage. Yeah, see how it's going up now that I've had this on? I just turned it off, turned it back on, now it's starting to climb back up again. 16, 15, maybe replacing those caps will bring that down some. And now I've got one more thing I want to check. and that's TIP 174 and 142. These Darlington transistors that we have here and here. I think this one's PNP and that one's NPN. But I want to look at those signals as well. Okay, so I have my oscilloscope probe. One on the collector and one on the emitter. I believe probe 1 is going to be the collector side, and probe 2 will be the emitter. So I'm just looking for a linearity as I increase my level adjust. Is the amplitude increasing for both? Now you can go ahead and see right now on the collector, and unfortunately I can't make this any bigger. I can't get this frequency in there any higher. You see we're starting to clip our circuit here. That's most likely because we're going out of range for this oscilloscope. But what happens is I switch over to 10 by and do it for both, and we'll increase again. Let's bring this down. You see how the audio is starting to clip, which that is fine because I'm overdriving that circuit. So personally, I think tip 178 is fine. Take a look at tip 142. And not much difference. It's pretty linear, and that's a nice signal. Let me take it out 1 by out 10 times and put it back into 1 by. And of course I would knock it off the lead and I'll short something out. There we go. And coming down more. Oh, that was too quick. All right. Again, I don't think those are necessarily bad. The signal looks clean. Looks like it is amplifying pretty in a very linear fashion. Okay, I have to get this guy apart, but it's going to be a fairly boring thing to record. I got to take all these caps off, unscrew everything. There's so many screws and stuff that I'm probably just going to do that off camera, get myself fairly organized. So when we get back, all you should see on my mat is just this board, and 3, 2, 1. It's magic. Well, I've gotten everything apart, and just want to say, yay, heat sink compound. Got it on my hands. We'll have to clean that up. It's rather dry. Some of it is still a bit, obviously, still a bit tacky. So, but I want to make sure I put down fresh heat sink compound on everything. Briefly looking on the other side of this board, I'm not seeing any. Zoom in a bit. Not seeing any broken solder joints. Any of these connect pots or phono plugs or audio plugs. But I did notice this darker side here. Let me turn off the light for a second. And if you flip it over, that corresponds to these diodes sitting right here. Boom, boom. That's those two diodes. And here is where we have that swollen cap. Putting it right about there. That's probably that cap there, and the other one's right there. So I'm kind of wondering, these diodes were working overtime and a lot of heat was coming up into this board. What is that guy right there? Yeah, it's going to be these two resistors here. Interesting. Well, I think these diodes, this I might have mentioned this in the last video. It might be a type of rectification going there, like a half-wave bridge rectifier or something. I don't know, but I think that's where our 16 volts, or technically it's supposed to be 15, is being developed. So we're going to check those diodes and may potentially replace them. We're already going to recap this board. Well, it's definitely worth something to note. Before we do that, I'm going to clean this up a bit. Also worthy to note was everything. This is the screw and nut that was used for the ground coming from our plug ACN. I mean, it was completely corroded. Same thing with everything on the transformer. And a lot of it, you can see down right there is a good example. A lot of it came off as I was unscrewing stuff, but there's just a lot of corrosion on the board. I'm surprised that it had a good, if it had a good ground to begin with. But so we're going to be doing a lot of cleaning of small throwawayables, call them throwawayables, nuts and bolts and stuff. But we're going to try to clean them up as best we can and reuse them. But all right. I've always found a dry wipe and wet wipe method works best. Usually I'll get a small paper towel, or even if it is like a CPU or GPU that has thermal compound on it. I always find it best to dry wipe first, because that gets the bulk of it off without having to use up so many Q-tips or wipes, and then a wet wipe with isopropyl alcohol afterwards to finish getting up everything that the dry wipe couldn't get off. But the dry wipe takes off really the bulk of it without smearing it around so much and making a huge mess. So that's my method. Other people have their methods, but that one's mine. bottom part of that chassis is going to need a lot more work. So rusted. All right, 0.6, rising 0.629. Well, these are slow to shut off in the other direction. Interesting. Wonder if I need to take them out of the board just to test them. So I also wanted to test our pots. Basically, there are 3 prongs on these potentiometers. I wonder if there's a way for me to do it. Yeah, I could go right underneath here. Try to demonstrate. Okay. And on these on the outside prongs should be the total value of your potentiometer. Okay. Now, that's why I need a third hand. All right, there we go. So here goes my first pot, 100K pot. Now, as I go right and left, I should not be seeing that change. It should just stay around 100K. And it's kind of varying quite a bit. Now, that's on the outside 2 pins. Now, if I have this fully canted over in one direction and go from, say, this lead here to that lead, I think it'll be at, come on. Yeah. So fully counterclockwise, outer left pin to middle pin. I know it's going to be hard for y'all to see. We're at 60 ohms, and as I go clockwise, oh, fell off that. I'll go from the bottom of the board. As I go clockwise, you should see it increase on the sweeper. So I got 100K on the sweeper. Now from pin center to this side, that should be close to 0 as possible. It's going to be my lowest. So, all right, with it fully clockwise going from center pin to this side, this should be low ohms. Now as I go counterclockwise, it should increase. Up into kilo ohms. All right. But at no point in time when I'm turning on the outer 2 posts should I see that that change. And it could be that just the pot itself is dirty, or it could be that it's physically bad inside. Not sure how much of that last video segment I'm going to keep. I'll probably just fast forward the majority of it. But what I wanted to point out is primarily these two pots are definitively bad. Now I thought for a second that these two were bad, but they are physically soldered from center pin to outer pin, center pin to outer pin. Now the reason why that is important is because when I take my leads, resistive measurement, outer pin to outer pin, there should be no change in value as I turn the potentiometer. But when I go to the sweeper and I turn the potentiometer, one way resistance will increase, the other way it will decrease, and the same thing for these sides. However, that is not something that I can test with these two because they're physically soldered together. That's how they're set up in the circuit. Regardless though, this pot has issues and so does that. That's something we're going to change. We're also going to probably remove these diodes out of the board and test them. And we need to get on to replacing all these capacitors on the board. So that is what is up next. Okay, so just off camera, so I go ahead and mark all these capacitors and then these two potentiometers, so I know which ones I've replaced and which ones I haven't. But I'll also have to get this, all this scholastic, this hot melt glue, scholastic, whatever it is, off. So that's what's time to do next. I'm going to take a second to show y'all something. Soldered this one in backwards, and the reason why I thought it was backwards is because these two posts right here are on a ground plane, and the original one had the negative rail not on the ground plane. And I was like, well, that's garbage. Maybe that's the reason why it went bad. But then I remembered sitting on this side of the capacitor is going to be a negative DC. And so 0 is actually higher than negative. So it's actually facing the right way. Just something to keep in mind. I've swapped that capacitor around. But let's test this popped up one real quick. And listening to Shango on my cell phone. It repairs a lot of televisions and whatnot. an interesting YouTube channel. I like his commentary. What do we got? $84, $85 on 100 microfarad, 35 volt cap. What is this one? Pretty much spot on. That one's probably good, but either way, still replacing it. We definitively know that one was bad. I want to say this one was not looking too shabby either. 47 microfarad. And it was, what was it sitting at? 50. Probably think that that's running a little high, but you know, I'm not checking for leakage or anything. So, getting rid of it. Something else I realized. I wish I had thought through a couple things. These 2.2 50 volt, 2.2 microfarad 50 volt capacitors, these are actually non-polarized. So I only have polarized. I will need to buy non-polarized caps for those, but I can continue on to replace the caps I do have on hand. I'll just have to get some of these ones on order. Okay, that's about as much as I can do on the capacitor front till I get in some non-polarized 2.2 microfarads. If you're wondering what kind of capacitors I use to replace, especially given the fact that form factor is smaller, I went with Rubicon capacitors. And obviously these are an older generation of capacitors, so size is going to be one of those things that you lose along the way. Tested these. They're both just shy of 220 microfarad. Whatever. Replaced them anyways. Alright. Got a couple more things I want to test and before we replace these guys. Just to show you that I'm not absolutely crazy, here goes the GX80 diagram again. And there's a lot more similarities with this diagram than the other one. But I was right. This is where you're making that positive 16 and negative 16 volt DC rail. And here go the two 35-100 microfarad capacitors. And here go the two 47 35 volt microfarad capacitors. And we swapped out both of those. And we should be getting 15 and negative 15, 16 feeding in, and we were pretty much not getting 15, we were getting 16. It's big old, that's two of those big 250 ohm 10 watt resistors that are up on the top. But here you go. This is what I'm talking about. This is your positive 16 rail. This is your negative 16 rail. That's what this represents. You're going to hit these Zener diodes. You're going to rectify. And then, as you can see on the positive VDC rail, the negative side of the capacitor goes to this ground here. But on the negative DC rail, the positive side of the capacitor goes to ground. Well, ladies and gents, this is where we're going to close out this portion of our video restoration project for now. Like I said, this is going to be a restoration project more than just a fix-it video. When we pick back up, because I have some concerns with preamplification, and I just want to make sure that the capacitors we're replacing will resolve all of our issues. We're going to test out our dual channel OpAmps in circuit and out of circuit if we need to. Same thing with our FETs, P channel and N channel FETs, and our transistors. And if everything tests out okay, then I am confident that this board will function as it should, the amplifier will function as it should. So we'll go through all that when we pick back up. Hopefully also have the 2.2 microfarad non-polarized capacitors in that we can get in and replace. We'll replace the potentiometers, and then there's still a lot of work that needs to be done to the physical aspect of the amplifier too. Now, this is an older Crate style non-tube based amplifier. It's not very popular, but there's not a whole lot of literature either. And so I'd imagine that people are still using them and they are running into issues. I would hope that they would be able to stumble across this video and find it useful for accomplishing a repair themselves. At least that's the intent of this entire series. Now, I will have other projects as well, along with standard fix-it videos that I'll be working on, especially because I do have some tube-based old radios from the 40s that I want to get repaired, and it'll be fun to demonstrate some of those projects through this YouTube channel. But anyways, if you found this content enjoyable, please subscribe if you haven't already. You know, thumbs up and thumbs down don't really mean anything nowadays, but if you give it a like, that's fine too. What I ultimately appreciate is your comments down in the doobly-doo down below, and engaging with each of you. But anyways, this is going to be it for now. Take care. Bye.